Have you ever pondered the process of calculating the power in an asynchronous machine? It's a question that can leave even the brightest minds scratching their heads. But fear not, because today, we're going to unravel this mystery together. First, it's crucial to understand what an asynchronous machine is. Also known as an induction machine, it's a type of electric motor where power is supplied to the rotor by electromagnetic induction, a phenomenon that allows an alternating current to induce a voltage. Now on to the calculation of power. There are three key components to consider: the input power, the output power, and the power losses. The input power, also known as the apparent power, is the product of the voltage, current, and the square root of 3, which comes into play because we're dealing with a three-phase power system. To calculate it, simply multiply the voltage by the current, and then by the square root of 3. Next we have the output power. This is the mechanical power delivered by the motor, and it's calculated as the product of the torque and the angular speed. Remember that the torque must be in Newton meters, and the speed in radian per second for the units to align correctly. The third component, power losses, is the difference between the input power and the output power. These losses occur due to various factors such as resistance in the windings, magnetic losses in the iron core, and mechanical losses in the bearings and ventilation. Now that we have these three components, we can calculate the efficiency of the asynchronous machine. Efficiency is the ratio of the output power to the input power, expressed as a percentage. It's a measure of how effectively the machine converts electrical power to mechanical power. In summary, calculating the power in an asynchronous machine involves understanding the machine's operation and its various power components. It begins with calculating the input power, then the output power, followed by the power losses. Lastly, the efficiency of the machine is determined. This process might seem daunting at first, but with a bit of practice, it becomes an easy-to-follow routine. So the next time you encounter an asynchronous machine, you'll know exactly how to calculate its power and efficiency. Now you're equipped with the knowledge to conquer even the most complex of asynchronous machines. Remember, the world of engineering is all about learning, problem-solving, and applying your knowledge to real-world situations. So go forth and let your newfound knowledge light the way,